Are there any questions on the shark bite we want to see, do, go over, or had questions about? If not, we're going to start our lesson for today. So everyone should have these notes in front of them. This is the last lesson of this unit, which means your quiz and tests are coming up. Quiz is Monday, test is Wednesday, so keep that in mind. This coming Wednesday is your flex day, your review flex day, so also keep that in mind. So the last thing we have to talk about with transformations is being able to graph using our transformations. So when we're doing this, you have to know which type of function you're graphing. Look at what's given. Do you see absolute value bars or do you see a square? That'll tell you if you're using absolute value or x squared, the quadratic. And then we're going to use our transformations to help us graph this. But what's also nice is you can check yourself in the calculator or do it in the calculator. I wouldn't know the difference. As long as you write the vertex and graph it correctly, I won't know if you did it by hand or in the calculator, using the transformations or in the calculator. So you'll have that option. So let's start with number 1. Both of these types of examples, you're going to start at your vertex. Your vertex can be found using the inside number and the outside number. But remember, the inside is opposite when you put it in the vertex. So this would be a positive 1 and 2. Because really that's a horizontal shift right 1 and up 2. So we're going to plot that point at 1, 2. Nothing else happened. It didn't stretch or compress. It didn't reflect. So that means it's going to look like the normal, except it just has been shifted. So that means from your vertex, you're going to go up 1, right 1 as many times as possible. And then up 1, left 1 from your vertex as many times as possible. And then draw a line through both. Make sure you have arrows at the end. You need at least 5 points anytime you graph these, so you can have more than that. You cannot have less than that. You have to have 5 points. State what your vertex is, so that'll give you 1, and then at least 4 others. Questions on that before I show you how you can double check yourself in the calculator? The vertex is based on these 2 numbers.
What do these bars have to do with it?
That tells you what type of function it is. Those are your absolute value bars. So it's going to be graphed like an absolute value function. A V, not a U.
So,
The U. Did that answer your question? Did you need me to go? Any other questions on that before I show you how to do that in your calculator? If you want to write the transformations off to the side of what happened, how you got your vertex, it would be a horizontal shift, right 1. So again, not necessary, but you can write this. And a vertical shift up 2. That's how we got those 2 numbers. Or by looking at the equation, either or. Reset your calculators before you do anything else. Second plus 7, 1, 2. put that equation into your y equals. So your absolute value bars are in, I want to say alpha trace, alpha window. I know it was one of those. Alpha window. If you press that, you'll get the absolute value bars. And then x minus 1 inside, plus 2 on the outside. And we're going to go into the table, second graph. Find the point that we said was our vertex, 1, 2. And then go out from there and make sure all of the rest of your points match. So we go out, it should be at 0, 3, 2, 3. 0, 3, 2, 3. And then negative 1, 4, 3, 4. And really that would give you your 5 points. Any more would just be extra. So that's why I said you could use the calculator, the table, as long as you write your vertex and graph it correctly. Or you could graph it using your transformations. Okay. Other questions on 1 before we try 2? Tristan, can you hit new session? Try again. 4, 7, 2, 4, 5, 8. Great. Let's move on to number 2. So again, start with your vertex. Look at the number inside, look at the number outside. What would that vertex be? Inside number is going to be opposite. How would we write that vertex? If you don't have anything on the inside or the outside, you would just put 0. So that would be where we start this function at negative 3, 0. Also going to mention, because we have the parentheses and the squared, this is your x squared function, your quadratic. So it's going to look like a U, not a V. But this one has an additional transformation that the other one did not. This one's going to be stretched by 2. So again, I'm going to do this in the calculator to double check. But if you remember the original, it started at the vertex, and then it went right 1, up 1, left 1, up 1. If it's stretched vertically by 2, the right and left is still going to be 1, but now it's going to go up 2. And then if before it went right 2, up 4, that 4 is going to be multiplied by 2, so now it's going to go right 2, up 8. Kind of off the graph, and then left 2, up 8. So we can see that vertical stretch towards the y-axis. So again, the transformation words aren't necessary, but if you want that as a reminder of what happened, you can put that. Questions on that before we put it in the calculator to double check? If you use the calculator for all of them, that's fine. If you do it transformation-wise, I would highly recommend that you put it back in the calculator, double check, do your points match. That way you're not graphing the wrong thing. I'm going to get rid of this and type in 2 parentheses x plus 3 squared. Go back into the table, second graph, find my vertex at negative 3, 0. and my points should match. Negative 4, 2, and negative 2, 2. And negative 5, 8, and negative 1, 8. Questions on that? Mm-hmm. So if you don't see your vertex, you may have to scroll up or down until you find it. Moving on to number 3. What would the vertex of this one be? Look at the number on the inside, the number on the outside.
0, -4.
0, -4. So that's where we would start. Besides the vertical shift down 4, I didn't put the horizontal and vertical shift, I'm sorry, the horizontal shift for that one, but I can go back and do that. So this one had a vertical shift but not a horizontal shift. It also did something else. Yes. What other transformation thing happened, or what else do you see there?
Vertical flip.
Mm-hmm. Vertical reflection, yes. It's loading. It's trying to. Christina, go ahead. It's just being slow. So that means instead of it facing up, it's going to face down. Because of the negative, yep. But nothing else happened. So this is your absolute value. So it's going to look like a V, but just down. So from the vertex, we can go down 1, right 1, as many times as it'll let us. And down 1, left 1. Same thing. I'm going to graph that one again just to make sure we did that correctly. You need a negative first. Alpha window gives you your absolute value, just x inside the absolute value, and -4, not -4 on the outside. And then second graph, our vertex was 0, -4. And then if we went out from there, -1, -5, and 1, -5. -2, -6, and 2, -6. And then the other one should be -3, -7, and 3, -6. Okay. Questions on that? What would the vertex for number 4 be? Because we don't have anything on the inside, it didn't have parentheses. So 0, 1. That means there weren't any horizontal shifts, but there was a vertical shift at 1. Do we have any other transformations that happen? Do you see anything else that happened there? Missing something? They were on this desk. Do you remember?
That's my mom's.
You're welcome. No, you're good. Did anything else happen here besides that vertical shift? Are there any other numbers or symbols besides that minus plus one? Okay, that's just our function in general. So besides that, there isn't anything else. That means our parent function really just went up one, the rest is going to stay the same. So if you remember what that is, right one, up one, left one, up one, I would say try to remember this because it'll be helpful for you. But again, you have your calculator, so you don't have to. Right two, up four, left two, up four. I'm going to graph that so we can double check that it's right. X squared plus 1. In our table, second graph, vertex was 0, 1. And then negative 1, 2, and 1, 2. And negative 2, 5, and 2, 5. And that's what it goes up. Okay, questions so far? Guys, make sure you're writing this down. 2 more, and then you'll have time to practice. So for number 5, what would our vertex be? 3, 0, yes. This is opposite of what the number is on the inside, and we don't have anything on the outside. So that would be a horizontal shift in which direction?
Right.
Right, this is opposite. Right, but then what else happened? What else do you see changed in the function? Yes. So that 1/2 on the outside, we're going to vertically compress by 1/2. So we can still start at 3, 0. It's absolute value, so it's going to be a V. So instead of going up 1, right 1, and up 1, left 1, this is now our slope. So we're going to go up 1, right 2. Up 1, left 2. And I would say, even though you could keep going more left, I feel like that was too far over. It definitely was. Try to make it even. So if you can only go so far to the right, only go so far to the left. And then we'll graph that one. Tristan, can you hit the screen sharing? That one for me. Yep. Thank you. So you can go ahead and start putting that in your calculator. Alpha y equals to get your fraction. So we said 3, 0 was our vertex. And then you really have to be looking at 5, 1, because we went up 1, but right 2. So 5, 1, 1, 1 should be our point. 1, 1, 1, 1. And then negative 1, 2, and 7. And those match. What questions do we have on 5 before we do 6? What would the vertex for 6 be? 0, 0. There's nothing on the outside, nothing inside parentheses. The vertex is 0, 0. That means there wasn't a horizontal shift and there wasn't a vertical shift at all. What did happen though?
Vertical reflection.
Vertical reflection because of that negative. It is a x squared, so that's your u, your quadratic, and it's just going to flip upside down. So almost like this, what was that, 4? But instead of going up 1, right 1, or right 1, up 1, we're going to go right 1, down 1, left 1, down 1, right 2, down 4, and left 2, down 4. Questions on that? And then I'm going to put it into the calculator to make sure we graph it correctly. Make sure you're using the negative, not the minus. We said our vertex was 0, 0, and then we have negative 1, negative 1, and 1, negative 1, and 2, negative 4, negative 2, negative 4, which are the points that match. Do we have any questions on how to graph absolute value or quadratic functions using our transformations or the calculator? So you could be working on a few things for the remainder of class. That's all we're doing today. Khan Academy, pass Khan Academy if you need to do that. The Khan Academy that just opened today on graphing absolute value equations and graphing quadratic equations in vertex form. On the back of the notes that we just did are a review for objective 3, 4, and 5. Wednesday you'll get an actual review for all of the objectives. And then there are more practice things in here if you want to graph any of these for additional practice. Let me know if you have any questions. Use this time wisely. Don't waste this time. If you are missing Khan Academies, use this time to get those done, ask questions, get help, all those things. You have this time to work.